Hi there, my name is Mr. Beep-Bop, as you can see right here, and today this is going to be, well, the last episode of our basic constructs in terms of the 4 operations of maths. So, we just have, just write in our title here, so we've already went over addition, subtraction, multiplication, so today our question to answer is going to be, why do we need to divide? Why do we need to divide? Why is it important? So we'll just have a quick look at that. So we've already went over addition and subtraction and multiplication, and we basically said last time that multiplication will just represent with the multiply symbol here, is basically the same as saying adding a bunch of times, so we'll just represent it with a few addition. Right. We also know, well, some of you might know that, in fact, hang on, we'll just draw a quick table. So we'll draw a quick table like this. Okay. This is going to be add and subtract. This is going to be multiply and divide. There's a division symbol there. Okay, so I've grouped these two together because these are two very basic things in maths, so I put them on the top. And then it gets a little more complicated, so I'll put these two on the bottom. But I've also grouped these together because multiplication is a bunch of adding. So this means that as far as my table is concerned, at least, the division would follow the same pattern, and it's just a bunch of subtracting. So let's explore this theory. We'll just put it over here. So division is a bunch of subtracting. Now last time we went over the idea of adding on a number line, and our example was 3 lots of 4 equals 12, and we said, right, okay, we're going to 12, and this should be 0 because 3 lots of 4 equals 1. So we're going to add 4 3 times. So add 4, add 4, and add 4 one more time. Okay, so we have got the 12 there. Now, in theory, using these same numbers, because it's the opposite of multiplication, and if we said 3 plus 4 equals 7, we can also say that 7 minus 4 equals 3. Then that means that if these are actually similar, then we should be able to say that 12 divided by 4 equals 3. So let's look into this. So again, we're going to have, because it's the same number line, we're going to have the same start and finish, so 0 and 12. Now, if this is linked with subtraction, then we're going to be going back. And if we're going to, well, how do we get this answer? What does this actually represent? And what I'm going to say is, if this is counting on how many times we're adding 4, then just maybe this is counting how many times we're subtracting 4. So let's try subtracting 4. So we subtract 4 here, and we get to 8. So we'll just keep track of this under here. Subtract 4 again, get to 4. Subtract 4 again. Oh, we've got back to 0. Ah, okay, so we're subtracting 4 3 times, and that's what we're actually measuring when we're dividing a number. So that's what division actually is, therefore. It's just subtracting a bunch of times, and it's seeing how many times you can subtract something before you get to 0. However, let's look at a more complicated example. and I'm going to log into one that I know is not going to give us a whole number, and I'm going to do this on purpose. So what I'm going to say is I'm going to get orange down here, and I'm going to say, right, what's 15 divided by 6? Now, for those of you who know the 6 times tables, you know that 15 is not a multiple of 6. But we're going to take 0 and 15 this time on our number line, because we're still looking at how many times it takes to get back to 0. And we're still going to start with the same number, whatever our starting number is, so 15. And we're going to try taking away 6. Okay, so we'll take away 6 here. What do we do? 15 minus 6 is 9. Okay, let's take away 6 once more. You can see we haven't quite yet got back to 0. We're on 3. Now to get back to 0, I need to take away 3. Now some of you may be thinking, well, not taking away 6. But we can look at what fraction this is of 6. So, what fraction is it? So let's say we have a circle over here, and we've broken it up into 6 equal pieces. So if I shade in 3 of these pieces, like so, 1, 2, 3. Now just ignore the bit where I've went slightly over there. So we'll just get rid of these little bits here, and this little bit here. And what I'm going to say is, well, if we split this directly down the middle, just get rid of these lines then. I can see another fraction here that we've actually ended up shading in. And we've ended up shading in a half. And what I think this means is that our answer here to this question is going to be, I'll just get my brush, 2, because we've taken away 6 2 whole times, 1, 2. And then we've taken away half of 6, so I'm going to say that's 2.5. Okay, now, if I put that into my calculator, I'll just see if I can get my calculator up on the screen. Let's find our calculator. Okay, so I've got my calculator up here. I'm not entirely sure whether you'll be able to see it or not, but I'm just going to put in 15 divided by 6. And sure enough, 2.5, otherwise known as 2.5. Now let's check this, because in theory we should be able to go back the other way by multiplying. So we should be able to say 2.5 times 6 equals 15. So let's go back on our calculator. We've got 2.5 and multiplied by 6, and we end up back at 15, which means that the answer indeed to this question is 2.5, which means that division actually just is a bunch of subtraction, much like multiplication is a bunch of just a bunch of addition. So once again, we're now going to go back to our favourite example of, oh dear, must have not selected that properly. Okay, so we're just going to get rid of all this. Delete this, and we'll delete this as well. There we go. Now I do have to just go back over this. There we go, that's me, Mr. Beep-Bop. So, let's use the example of our apples again. So we've got an apple. There we go. And we're going to draw 12 apples. So the way I'm going to do this is I'm just going to select this like this. As I control, there we go. And there we go. Just copy these like so. And I'm going to get 12 apples. By taking this. There we are, 12 apples in total. So we'll just make a quick note of that. We have 12 apples. Now, you go to a market. You're selling these 12 apples, and you go to a market, and each day you sell 4 apples. So you sell 4 apples per day. Now, in previous videos, which I would encourage you to go back and watch if you haven't already, we discussed how if you're selling the apples, then that is clearly a subtraction. And if you're selling 4 apples per day, then this also links into division. And that's what a question would ask you to do. If it was asking, right, how many days will it take before I run out of my apples? Before I've run out of all 12 apples, I've sold all 12 apples, how many days will it take of me selling the apples for me to have sold all of them? And if we sell, if we're selling 4 apples per day, and we have 12 apples in total, then this is just seeing how many times 4 fits into 12. So we can go back in our number line again, if we want to. That is just lopsided really. So we'll just go back, and I'll put the numbers in a moment. But I know we're going to be going back this many times because we have done this subtraction before. So we're taking away 4, and we're going to do that 3 times. 1, 2, 3, which means that 12 divided by 4 equals 3. Okay, and there we go. That's how it applies in the real world. And just as much as we need multiplication, this is just going to work better with division. So we said, another example that we used last time was we said, if you have, if you get 12 apples per day for 75 days, you're going to end up with 900 apples in total. And let's say you sell 75 apples a day, right? And we want to know how many days it's going to take, so we're using the exact same situation, except we divide by 75. Now, if 12 times 75 equals 900, then this means that this should be 12. And I would draw that on a number line, but it would take me a while. It would take me a fair bit of time, so I'm not going to do that. Now, there are a couple of ways we could do this. We could say, obviously, go along the number line route and say, oh, minus 75, and then just counting up the number of 75s that we've taken away before we get to 0. Or we could do what I was taught as being called the bus stop method, where we put the 900 in here, we have 75, and we're going to end up with 12. Now we'll go over this method here in a later video, but for now I think we've pretty much covered this idea of why do we need to divide. So I'm quite happy to leave it there. If you do think that you still have some questions about why we need to divide, please feel free to put a comment on this video. I will look over them and answer any queries that you may have, and maybe even do another video if I think that it's necessary, just to go back over and delve a little deeper into these ideas of why do we need to divide. Okay, so I'm going to leave it there. I've been Mr. Beep-Bop, signing off. Bye bye.